and start the presentation here. So, yeah, thank you everyone for joining and joining us in this security camera networking, bandwidth, and architecture kind of one webinar we're going to be doing today. And today's agenda, we're going to be talking about bandwidth concerns. We're going to be talking about the different network architectures that exist within security cameras. Um, we're going to also talk about what happens when streaming occurs, right? That's also a big concern, as we can kind of see from the poll there too. We're going to talk about the multi stream options as well as video settings. Um, we'll talk about some tips and best practices, and also have some Q&A time at the end if anybody does have any questions. So, um, if you're not familiar with SCW, we are a value-driven company that provides end-to-end security solutions. So whether you're looking for a brand new system, revamping a system, whether you want to install it yourself or get turnkey installation, we can kind of provide all that. And for our dealers out there, we do have a great dealer program that offers a lot of value for people who are installing SW equipment as well. And then really what came to fame, and one thing that I think we'll introduce, especially for our current customers here, that are world-class support, right? Um, Security camera systems, especially when they get large, can be complicated. And so having free US-based support that you can call or set up schedules or whatever you want to do is a huge, huge advantage. So diving right into it, one of the questions that we get, especially from early on, especially from the IT positions, are how much bandwidth will this system use on my network? There's concern that, either from the local standpoint, like we're seeing here with the poll results, a lot of people are concerned about their local network. Um, but there's not a real, sometimes people don't always know how much these systems use, and the answer really does depend on a lot of things. Unfortunately, you can't just put an answer on that because it depends on how we set up the system, how we design it. Um, so there are a couple different ways of setting up in a security camera system, each with their own advantages and disadvantages. And first thing I want to talk about is a system that's based on an NVR, or a central recorder. So for those who are not familiar, an NVR stands for Network Video Recorder because it records IP cameras. And the NVR records the video, it centralizes the camera, it's where you interact with the system, etc. It's kind of the central controller, the brains of the system, really. And when we are dealing with an NVR, we're really dealing with two different network architectures. There's either cameras on the client's main network or cameras on a separate, um, what we would consider a camera network. So let's take a look at that. Um, when we have cameras on the network, and this is a very, very basic diagram here. So, in order for the cameras to reach the NVR in this case, they've got to go through the switches that we have into the network, whether that's a switch or a router, and then into the NVR constantly. So that's a constant source of data that is going to constantly be on your local network, because in order for those cameras to actually record, in order for that live video to get to the monitor and for people to be able to see it on their screen, it's a constant source of data at all time. We'll talk about how much in a little bit. So like I mentioned, the IP cameras need to get back to the NVR to record. So there's a couple things with this. Obviously, number one, we're talking about bandwidth use, which again, for large systems is not insignificant, for sure. But the other thing too, is the camera reliability is going to be tied to the network reliability. Um, we have clients all across the board when it comes to IT. Some of them have stellar networks that have great reliability, great capacity, etc. And then others that don't have, any expertise there at all. And so we try to avoid, when we're designing a camera system, we try to avoid putting cameras on people's networks for reliability, for bandwidth purposes, as well as there's security benefits as well. So what do we do instead? Well, what we do is create a separate camera network, and it looks something like this. Um, The main advantage, let me actually go through it a little bit first here before I go back to that. But the main advantage of keeping them separated is that um, at rest. So what that means is that nobody is streaming it, nobody is on their computer streaming it, nobody's on a smartphone streaming it. That at rest, you're basically using zero bandwidth because the cameras are going in directly to the recorder. So that means your local network is not bearing the brunt of all these security cameras. The other advantage is that camera reliability is no longer tied to the network reliability. So, there's an issue with the network, it's not going to affect the performance of the camera to the NVR. And then the other advantage to this too is that when we separate them, it's a little bit of a double-edged sword, right? So when we separate the cameras from the main network, you do lose some visibility with that. But on the positive side, it's really just a network you don't really have to generally worry about. Once we set it up, once we get it all configured, it's 30, 40, 50, however many cameras you have, less devices to worry about. And when it comes to separate networks, there basically are two ways to achieve this, right? The first one is for our smaller systems out there. These are the ones that are like 24 and below cameras. So anywhere between there. Typically, we're doing something like a plug and play setup. So on the back of the NVR, we've got PoE ports. This actually creates a separate network for the cameras. And so we plug the cameras directly into it. And if this router goes down, the network goes down, whatever, it's not going to affect the camera's ability to get to the NVR, to record, to present live view, etc. Um, and so the same thing is that the bandwidth is not occurring across the network unless somebody goes on their PC over here or their smartphone and brings it up on the web or through the software. So this is a really simple setup because all the network is basically done for you. You simply plug in the camera, it gets it done. It's really, really nice. But what happens when you have a larger system? Um, so since we're topped out at about 24 ports built into most of these NVRs, we have to create a secondary network altogether. So what you see here is a lot of our larger NVRs, they either have dual network ports. So in this case, you can see that we have one network port that's going to go to the main network. And what that's going to enable us is for you to have remote access, to be able to see it on your phone, computer, and then the second port creates that camera network as well. So it's a completely separate, isolated away network that is not going to use bandwidth on the main network and is also put away for security reasons as well. So you don't have to worry about having 64 cameras you have to constantly refresh passwords and all that. It creates an isolated air gap network for you. Um, Obviously there are other ways. This is a very simple diagram again here, but in this case, we're going from one switch into another switch and then into the NVR. Of course, for larger systems, we'll typically use what's known as an aggregate. So what that means is we would have a switch before. So you just kind of would go from a switch here into the main NVR, the port number two, and then we would plug these in here as well, and whatever other PoE switches. So there's lots of ways of achieving this, but the key thing is that none of these cameras have to touch the main network in order to perform their duties. So, like I mentioned, that the multi-network NVRs, whether it's our larger ones with four of them built in or two of them on our other large ones, they kind of achieve that similar result to plug and play, where the camera's just away. You don't really have to worry about them. They're almost don't even seem like they're an IP device in some ways, just because they're away, they're out of picture, out of mind. Um, and so just achieves that on a larger scale. So it gives us systems that as large as 256 channels on a single NVR that will use near zero bandwidth at rest on your main network. So that's, one of the main reasons why, we really try to push that, especially in the early stages and depending on the infrastructure, what's available, to be able to do that. So to recap that a little bit, and I know that was quite a bit, is the system bandwidth use, when we go back to that main question we asked, which is how much bandwidth is this going to use on my network? There's a lot of variables. And the system bandwidth use, the reliability of the system, the performance of the system all stem from that initial design and how it's going to, work. We recommend doing separate camera networks when possible, but I've had other clients too that want all of their cameras on their network because they have managed switches and they have the capacity and they know how to handle it, and that's fine as well. It's just that you know, for most other people or people who don't want to take that task on, the separate network kind of, eliminates that need. Now, the other camera network architecture out there is kind of a newer one, right? It's your cam to cloud providers. So these are ones that they don't have an NVR, and they are only on the camera. So how this typically works, and there, of course there's variations, but a lot of them work the same, is the cameras themselves have storage built into them. So they record on the camera, which again, it kind of achieves that little to no bandwidth at rest, like we achieve with that external, the separate network. Now, one of the things about cam to cloud to consider is that um, when somebody is using the system, whether it's pulling up the video or just looking at them live from any option, it is going to bump up that bandwidth use. So here's kind of a diagram of that, right? So you've got cameras with built-in storage. They go into the PoE switch on the main network, and then they go into the an internet-facing network. So you know the cool thing is that with Cam to Cloud, there is some achievement of using very little bandwidth when it's at rest. But the general question we have after that, when we talk about that, is, well, what about when somebody is actually using the camera system? Obviously, we get security camera systems to use them, and there's different variations in use. Some people are using them every single day to perform their job tasks, like in production monitoring, obviously for security reasons, just the front desk people being able to see who's there, everything in between, right? So, what happens when somebody is using the camera system? Well, there's a couple things that we can do to kind of work with that, right? One of the main advantages of an NVR, one of the advantages of an NVR, is that you're also getting, not only are you getting the recorder, like I mentioned, the recorder, the settings, and the brain of the system and all that, but you're also getting a free viewing station as well when you think about it. So on the NVR, we have video outputs. There's HDMI. In this case, you can see we got two HDMI, two VGAs. And these outputs can be sent to a dedicated TV or monitor. And from there, you have full operations with a mouse. You can do playback, you can change settings, etc. All there with using zero additional bandwidth. So when you're streaming it from that local, there's no bandwidth being used, any additional bandwidth being used within the system, right? So, this is a really big thing because when it comes to streaming, there are a lot of industries, like I just kind of alluded to, that or positions or people that require always on security cameras, whether it's in the security team, kind of the most obvious. There's a lot of requests when we go to install a camera system, no matter the location, there's always people who go like, oh man, I want that video, right? When we're in a car dealership, all of a sudden the managers want to be able to see the showroom floor and they want to be able to see the car lot because they want to make sure people are going and you know talking to people when they arrive and so on. So there's always a lot of demand for access to live video. We find more than most people even think about in the early stages. And so we want to get that video to these people who are relying on the video with the minimal amount of resources being utilized and the best experience possible. And that's what that dedicated display option gets us. Now, what happens when you have cam to cloud and you want to have like a dedicated display from the manager or the security team or well, that's when it comes into there is no NVR, there is no recorder, so you don't get that viewing station that's built into it, right? Um, and so that means that you're either going to have to open it up on the web browser, bring it up, that's going to use some bandwidth. Or you're also going to potentially have to source a hardware device to do that. So if I want to have, um, 32 cameras on the manager's wall over there on a TV, we're going to have to source a device, an additional device to achieve that. Usually, a PC. And again, what about that? What about streaming on a computer or mobile? Like what if they're too far from the recorder? What if they're away from the location and so on? So whenever, no matter the architecture, so whether it's cam to cloud, whether the cameras are on their own network, for the most part, when you're streaming to a computer or your smartphone, you're going to start to use some bandwidth. And the question is how much and what type of bandwidth will we be using? So this chart here goes over basically what a typical security camera actually uses. And these are our defaults. There's going to be variations out there as well, but this is pretty standard across the board, I would say. So we got a couple of columns over here. The first one is the resolution and the frames per second. So if you see over here, 1080p or 2 megapixel at 15 frames a second uses about 1 megabit per second of mainstream bitrate. And if we look at the next column, you see this is also 1080p at 30 frames per second. And you see that this uses 2 or double. So the reason for that is because we've got literally twice the amount of images in the second, so it's going to use twice the amount of data. This also applies to your storage, which is why in a lot of cases you may consider reducing your frames per second because the data, the bandwidth it's using also directly translates to your storage, which we did have a webinar on, by the way, as well, if you're interested in that. But as we go up here, you can just kind of see, we got 4 megapixel at 30 frames a second, uses about 3 megabits, 4 megabits, depending on the camera. Then we get up to the 4K at 20 frames a second, about 4 to 5 again. And then when we get to 8 megapixel or 4K at 30 frames a second, we're looking at 6. Now, if we get rid of all this, we notice on the other columns here that we've got something called H.265 and H.264 over here. So all of our cameras use H.265. This is the newer, more efficient standard for compression on the cameras. And so what that ultimately means, and you can see it right here, is that it basically cuts the amount of data in half. So, back in the day when we had H.264 cameras, a single 1080p camera used 4 megabits of data, whereas nowadays that uses 2. And so it's cut the amount of data basically in half, and also has basically doubled the amount of storage we can get out of a certain size drive, and so on. So, if you have an older camera system out there, it's very possible that you're on H.264, and if you're struggling with bandwidth, that could be a potential solution just right there in upgrading the cameras, and you just cut your bandwidth in half. So, the other column over here too is the substream and other data, and third stream and other data. So you can see we basically say that uses about 1.5 megabits per second across the board, which gets our final bandwidth count for the cameras over here on the far right. So you can see, a typical 1080p camera at 30 frames a second would use about 3.5. A 4K camera at 30 frames a second would use about 7.5 megabits per second per camera. So speaking of multiple streams, what is that? What is that substream, third stream? What does that even mean? So when it comes to streaming, right? Nowadays, 4K cameras are the most common cameras that we sell, and that's actually been the case for a while. The industry, I'd say, is probably around 4 for most people. Maybe 5 is also a pretty common one. But 4K, as you can imagine, is, as we saw there, is a lot more data. It's also a lot more processing power and all that too. So how do we, if we have a camera system of 32 4K cameras, how does somebody view it on their computer? Um, and multi-streaming is what makes that possible. And it's utilized by almost all major platforms. I'm not going to say this is specific to SCW or anything like that. There are some options out there that make this more automatic than others, which makes it easier. Um, but if you think about YouTube, right? If you're on your phone and you're in an area with maybe poor reception or your Wi-Fi kind of might be slow, it will switch between those video streams, right? So all of a sudden you get really slow network, it will kind of reduce it and show you kind of a lower quality video to make sure you don't have buffering and you don't freeze and all that. It's kind of similar to that in some ways. And so our systems have three different streams. The first one is the mainstream. And so the mainstream is the highest recorded quality option. So if it is a 4K camera, it's 4K. That is it's gonna be whatever it is. Like I mentioned, 4K, it's a decent amount of bandwidth, it's a decent amount of processing power. And another thing too is it's really impractical. If you have 32 cameras, right, you're not gonna be able to see 4K detail when you're looking at a single 4K display, right? So it's kind of impractical to actually to be able to display more than a couple of 4K cameras at a time. So in general, the mainstream is only used when you're looking at a single camera view on the platform, and we'll show what that kind of looks like. The other stream, the second stream, so this is either known as the second stream or potentially also the substream. And this is like your middle ground option, right? So it's typically set around 720p for our rollouts. It could be lower if you want to. It is customizable. And typically it uses about 1 megabit per second. So, if you think about that, that's already significantly less than the six or so that the mainstream's going to use. And then the last option, the third stream, is the lowest of them. So this is generally around standard definition or 480p, or you can set it even lower if you want to. And it's good when you start to big grids above 8. And so the key thing with the third stream, right, is that it uses 95% less data than a 4K mainstream camera, which makes streaming remotely possible, even when you got maybe not the greatest internet connection. And it typically, again, uses anywhere as low as 128 kilobits per second or all the way up to, 512 kilobits per second, which is, half a megabit, which again is 95% less data than what we would typically use for a 4K camera. So I kind of want to demo this real quick for you guys, just to kind of show you what it looks like in the real world. So I've got our ViewStation software up here, and I'm going to bring up, let's just say 9 cameras here. We'll do it with our main office. Actually, let me switch to warehouse. A little bit more going on here. Um, and we'll see that by default here, because we are in a larger grid, that it sets it to this third stream. And you can see what some of these are set to. Like this one right here is using about 190 kilobits, 185, 170. This one's at about 500. This one's about 500, especially as we just saw that car come by, and so on. But if I were to, double click over here, so if I double click this one, for example, it automatically switches over to the mainstream, which is our 4K stream. You'll see here it kind of goes down to, 6 megabits per second. This is a 30 frames a second camera. And if I go back, it automatically switches as well. So it's pretty seamless. That's the first thing I think is important, that the user itself does not have to pick. We don't have to worry that somebody's going to overload it accidentally potentially with this. The other thing too is we can manually override that, and I just kind of want to show you, if we pay attention to this middle one here, what that kind of looks like here. So if we switch it over to Substream, um, you can kind of notice a difference. Maybe it looks a little bit clearer, but really not when we're looking at this amount of cameras on a screen this size. And if we go all the way up to mainstream, so now this is actually a 4K grid, and believe it or not, as you can kind of see, it actually looks a little worse than what the other two look like, because it's trying to squish 8 million pixels into this box that's, a couple 100,000 pixels wide. So it's not going to be the best experience. And on top of that, we're now using 95% more data than we were using at substream or third stream, excuse me. So yeah, this is just kind of a live example of what that looks like. Again, you can double click, gets us to our high quality, nice 4K view. I double click, go back. It gets us back to that third low bandwidth kind of option. And on top of that, one of the main things I need to make sure everyone is aware of too is no matter what we're looking at. So even if I go over here and I switch this over to third stream or substream or whatever, it's not going to affect what the recorded quality is going to look like. It is always going to record at that mainstream quality. So no matter what you're viewing it at, it's not going to affect that as well. So, all right. So a couple of things. A couple things that we got some questions at, and feel free to answer any question or ask any questions while I go through these as well. Um, but one of the questions that we had is why we have lag on mainstream. That's the main issue we face in our environment. So when it comes to mainstream, there's a lot of variations, right? There is either a network resource issue. So maybe, especially if those people are remote, we may need to check about the upload speed and everything. And we'll go over that next, actually, when it comes to remote users. But if they're in the network and they're in the main network, the local network there, the other thing to consider too is when we're talking 95% more data, we're also probably talking 95% higher computer usage as well. So in order for you to look at a 4K camera, or especially if you're trying to look at multiple 4K cameras, then you're in a situation where, the processing power needs to be significant in order for you to smoothly view that video, right? And so again, to get not to get too specific on your use case, and I would definitely, if you have an SCW system, reach out to us, and we'll have ask you for some information and everything. But for the most part, we need to figure out, um, the computer, the way you're looking at it, etc. But main thing I would consider is if you're looking at more than four cameras, I wouldn't be looking at mainstream. That's kind of my main point there because you're not going to probably see the quality difference at all. Realistically, I would set your substream to 720p and then use that as the option because that's going to use a lot less data and processing power as well. And then we have another question, also hoping to tell us if it's possible to change settings across all cameras at the same time. It is, at least in our systems. Again, you can go through and I actually will actually had one open here just earlier to kind of talk about that too. Um, but like for example, if we were to adjust some of these settings, like if we wanted to change the substream to let's just say we want to use it to 512 instead of the two 1 megabit, you can set that and then copy the parameters over. So we would just want to copy the substream and all that, copy to the rest of the cameras, hit save, and it will actually send all of that information over to make that adjustment as well. So it is possible, and I would just go ahead and reach out to support if you have any issues doing that. All right, now back to the presentation. To the point I just talked about with that other question too is hardware is a limitation as well. There's limitations on the actual client, so the computer. Like I said, 4K is a lot. If you go and try to bring up two 4K, three or four 4K streams from YouTube on your computer, you'll see kind of what that looks like, right? It starts to stutter on a lot of computers and so on. So that's a limitation. Um, Another limitation to consider, especially with streamers, and is there could be hardware limitations as well. So in terms of the NVR, for example, only being able to stream out so much data or so many streams and so on. Each of these ones are going to be different. So I would definitely, again, look at the NVR specs and see what's option there. If you have our systems, typically it's around 128 streams or more on the larger ones, but um, and there are ways to help with that too, and that gets into the more one-to-one, which we'll talk about. But I did want to kind of put this um, into sort of like a scenario, right? So in this case, this is a 45 camera system, and we have a couple people who want access to the camera streaming, or they need the video, right? That's the request, and so we got John, the manager. He's going to want constant access to all 45 cameras. He wants them on a big TV. He wants to be able to see everything. it's going to be a big part of his job to kind of watch and see what people are doing. Um, then we have Samantha in operations. She needs access to the production area, so this is a manufacturing plant, and that's going to be 16 cameras worth. Now, Jeff at the front desk, he's going to want to see the entrances, the lobbies, maybe some of the parking lot. That's going to be about 8 cameras as well. And then we'll also, of course, have occasional viewers as well, like the HR might come and pull some footage for safety. Some other people in operations may pull something. So, what does that really look like? What are we going to recommend for that situation, right? To go back to what I mentioned, offer the best solution with the least amount of resources utilized. So when it comes to John, the manager, the guy who wants to have all the video, nice big screen up there, I'm going to recommend let's get him the local view. Because what that's going to offer us is that's the HDMI, by the way, outside of the NVR. That's going to offer us a zero bandwidth, zero additional bandwidth solution for him. No matter, that video is always going to be there. It's always there no matter what. So we're not using any more bandwidth to actually get that to him. We also don't have to go and get him a $1,000 PC. I'm not sure if you guys have seen PC prices lately, but they are going up and up because of AI and all that fun stuff. So, we're going to save him $1,000 right there. This company $1,000 by not having to have a PC. Um, and then to that point too, since we have a lot of IT audience on here and some non-IT. Anytime you, of course, add in a PC, especially if you're purchasing it, it becomes another thing that you have to manage. And we're avoiding that as well. Samantha in operations. So this is where, we get to Jeff and Samantha. This is where we are going to be using a computer or something else, right? So Samantha in operations, if she's looking at 16 cameras at third stream, that's going to use about 8 megabits per second. And then Jeff at the front desk, if he's looking at 8 at third stream, we're looking at about 4 megabits. So with proper design, if we're doing a isolated network, if we're doing what we're recommending here, this system is going to use less than 15 megabits of bandwidth during operation. Or another way of putting this for people who are not network savvy, it's about 1.5% of a gigabit switch's capacity. And all local, so in theory, basically 15 megabits is very little to nothing for most networks, right? And we do have a good question. Wouldn't the local video from an NVR require existence extension or existence of an HDMI cable if the NVR is in a rack-mounted one? Absolutely right. So that obviously there's two options there, whether the NVR is close enough to get him a real HDMI cable, or number two, there are also HDMI extenders out there that run it through a dedicated CAT cable, so it doesn't use bandwidth on the network, but still allows us to have the video and the mouse all across the facility. So there's AV products that we use to achieve John the manager getting access, even if he's, across the other side of the facility, basically. But really good question. Now, what about people outside the facility? We just talked about 3 people who are working inside the facility. What about the people outside that, maybe your upper management, maybe other people who are maybe it's a centrally managed kind of location. Um, well, when it comes to viewing remotely, we're still going to utilize everything we just talked about, right? We're still going to utilize the multi-streams, the third stream, the substream to minimize the data use. But what we really need to start to be concerned about for those remote users is at the facility, we need to double check what is the upload speed at the location. So because you're sending video across the internet to another person, the place, let's just say the manufacturing plant, that's where we need to consider the upload speed. And then let's just say the central office, where they're going to be viewing it more frequently, or wherever they are, we need to be concerned with the download speed. Um, for most people, like I mentioned, 15 megabits. If we look at this, for those 2 people viewing it on their computer, um, is not typically a huge amount of data for most modern upload speeds. Although it's just going to depend on your location. So if you're not sure what your upload speed is, your upload capacity, you can either check with the internet provider or your IT if you've got it, Or you can also just go and do a speed test. If you go to speedtest.net, you can pull that up. It will let you know kind of realistically what you're getting. And when it comes to download speed, it's the same thing. Most people do seem to know their download rather than upload, but usually the download speed is very rarely ever a bottleneck. You'd have to have really kind of slow internet for that to be a consideration. It's usually the upload speed is what we care about first. I'd also be a little remiss if I didn't mention security when it comes to remote access as well. This could be a webinar in itself, and we did actually cover some of this when we talked about, the path to modernization when it comes to security camera systems. And the big thing I want to just put out there is there are a lot of different ways of accessing a system remotely. You've got, cloud P2P services, like the ones that we utilize in most cases. There's also private VPNs or tunnels, so like Cloudflare, Tailscale, some people use that as well. Um, and then there's port forwarding. So port forwarding means you go in, you basically release this device, your NVR, to the entire internet. Um, and that kind of used to be the standard like 5, 10 years ago, right? That's just how things were. You just port forward if you want a remote access. But of course, AI has really changed that. It's now it goes from being, not wasn't always the best practice. People kind of knew there was risk associated with it. To now, it's very very dangerous to do because of AI and the ability for people to kind of scrub the entire internet within a couple of days and see devices and all that kind of stuff. So we definitely do not recommend port forwarding. Use more secure options like cloud relays if it's built into the NVR or a private VPN or tunnel. That is the most secure because it's only between you, but it also is the most amount of IT work and setup as well. Now, one of the last things I want to kind of mention before we get to the end in the Q&A here is, um, you know, expertise and one-to-one consultations. Whether you're in IT or like the poll question said, you're trying to make sure IT still likes you after you get a new camera system. We're happy to help with expert consultations. Bring your IT team on. We'll show them how it kind of set up, what impact it's going to have on him or her, and what preference they have. Maybe they want it on their network for visibility. That's absolutely fine, and we can design it that way as well. Um, and we can work with you on a one-to-one system design and explanations as well. And make sure that your system is not going to be a burden on your network, whether it's local or remote. And with that, that's kind of the end of the presentation. I'll open the floor up to any more additional questions that we have. And I do want to mention as well, for people who are, on this webinar who are currently experiencing bandwidth issues, feel free to reach out to us, right? We will work with you. We have a form that we're going to fill out or have you guys take a look at that. We'll gather some information and then you'll work with one of our experts to kind of figure out what the best possible solution might be for you or where some of the issues are. Sometimes it's just a configuration issue that we can adjust and seriously reduce the amount of bandwidth. There's a lot of settings that we can do. So we need to take like a chisel approach, right? We need to kind of go in and just figure it out. We're not going to go and immediately just tell you like, hey, we need to start everything from scratch or anything like that. We're going to make sure we understand your solution, your situation, and present the best solution, whether that's a setting change, whether that's a setting change on the software, or it's maybe more it's more of a configuration or physical change that that's possible as well. But we'll make sure we go through all the avenues first before we get there. So yeah. So any other questions? Feel free to put them in there. But Dylan, anything else that you wanted to cover before we jump off?
Oh, I think that's it. Once this video processes, we'll upload it, send the recording, recap. Feel free to reply to that email as well. We'll get them. Um, that's it, really. Nice work, James. I learned some stuff for sure. Pretty interesting. Anytime you said zero bandwidth, my ears perked up throughout that. That was good.
Awesome, awesome.
Looks like we got a couple new ones coming in.
Yeah, and I do see one specifically just about view station. Currently using auto logging configuration. Display authorized cameras. I might want to reach out to you more directly just to understand your use case a little bit. When we do the auto login through ViewStation, that is kind of the access. Now you can set up user accounts within ViewStation to limit what cameras people have access to. So the question, from my understanding, is just basically, um, how can we limit what cameras and everything people have? You can do that within ViewStation through that, but you wouldn't be able to do the auto login. If it's a shared computer, we typically don't recommend doing the auto login as much. The auto login is more specifically for, nobody logs into my computer here, so I always auto log in or something like that. But I would definitely reach out to us and we'll work with you more on a one-to-one scale. I'm glad you're having good success with support as well. Um, Other question is, are you aware of any issues with SCMGO through an open VPN tunnel? I haven't heard any issues. I don't, assuming that, I access through VPNs, so, assuming it's just a standard VPN, obviously you would need the VPN configured on the phone or the device before, it would connect. But other than that, no, I haven't heard any issues. Now, I will mention there was a follow-up to that just about SCWGO reporting that like there's it's slowing down or network issues or something like that. I will mention that when it comes to VPNs, typically and not always, but typically they'll also just depending on like what hardware you have and router and all that kind of stuff. It also may limit your connection speed as well. So you may want to double check that to see kind of what streaming capability you have there too, when the VPN's enabled. Another one is smart encoding make a difference in bandwidth, or is it more of a storage side? It can make a difference because the storage, the bandwidth is the storage, and they're linked, right? Now I will say with smart encoding, my experience with it, in the most cases, whether that's like called H.265 Plus or smart encoding or whatever they call it, especially for like really busy cameras, it doesn't make a major impact on bandwidth or storage in my experience. I will mention that, and this gets into a custom setting, or not really custom, but we use this more for storage reasons. But there is a setting here, and actually we'll show it again, not to get too into the weeds, but everything. But like when we look at our settings here on the NVR for the cameras, the encoding settings specifically, you'll see that we have two different stream types when it comes to mainstream. We have what's known as normal. So normal refers to when nothing is occurring on the stream that it detects. So no motion's being detected, no analytics are being detected. And then we also have, if we click this, something called event. And what event allows us to do is when one of those are detected, so whether it's motion or an analytic, a person or vehicle detection, we can have different settings for that. So, for example, where that comes in handy is, let's just say when nothing's being detected whatsoever, I could reduce this camera that usually is using about 6 megabits per second down to, let's just say, 2000 or something, reduce the frames per second so it's not all kind of garbly there. We'll do that. Oop, I don't want to do that for all of them, but I'll have to fix that. And then we go to event, and you notice that it's still set to the normal frames per second and the bit rate. So basically what that means is that we can set the non-activity to a very low amount of data. And then when it detects activity, it can bump up to the nice, beautiful 4K 30 frames a second at good quality. So that can also reduce bandwidth and it helps reduce storage, especially for those people who can't record on motion. We actually talked about this at our storage webinar, because that's usually where we do it, but this can actually save bandwidth as well. And if you're interested in it and you want a little bit more of an explanation, we can definitely talk to you about it on a call as well. So, all right, give it just another minute here for any other additional questions. But yeah, you guys will be getting an email. Did you go over that, Dylan? I can't remember.
I did, yeah.
Okay.
Yep. Yep. Give it takes like 20 minutes sometimes to process. So
Yeah, you guys will get the recording for this. And again, feel free to reach out to us. We're happy to help kind of go through everything. Do appreciate your guys' engagement and interest in this topic. And um, other than that, we'll think we're good for now. Any last things we want to know, Dylan?
I think we're good. I think no more questions. Again, we're going to send an email. Feel free to reply to that or
Yeah,
contact support directly for something more in depth. And yeah, other than that, good job, James. Awesome,
yeah,
as always.
awesome. Well, thank you guys again, and see you on the next one. Bye
All right,
bye.
see you guys. Bye.